Hi, welcome to Build Picker. I'm John. In this video we're going to be taking a look at Intel's new 13th generation of CPUs, codenamed Raptor Lake. We've got the i9-13900K and the i5-13600K here to test, and we'll be running them through a suite of synthetic benchmarks to gauge their multi-core and single-core performance, as well as some gaming benchmarks as well to see how they stack up there. We'll use this information to make some recommendations to you as to which is going to be the best choice for your next PC. So stick around and let's dive into the new CPUs from Intel. This 13th generation is an evolution of last year's 12th generation CPUs, the older Lake generation. They saw a big shift in ethos, with Intel combining high-performance P cores with smaller, more efficient E cores on the same CPU die. Intel's argument was that this allowed highly scalable CPU power without too much cost, either in expensive CPU die area or in power use and the resultant heat that generates. By and large, this approach worked well, with the older Lake CPUs offering strong products. Up at the high end, the i7-12700K and the i9-12900K showed themselves to be really powerful all-round CPUs. Raptor Lake then sees Intel refine and advance this architecture. The flagship i9-13900K now boasts 16 E cores alongside its primary 8 P cores. And there are some pretty tasty numbers on the stat sheet as well. 5.8 GHz boost clocks and 32 MB of level 3 cache are a healthy step up from the last year's i9. However, they appear to be coming clean on power use, with a quoted 253 watt power draw under load. We'll talk more about that later. The i5-13600K is the mid-range enthusiast CPU, but it gains 4 E cores from last generation to make it a 6+8 core CPU, with 14 physical and 20 logical cores. Confused? Don't worry, I am too. Nonetheless, with a 5.1 GHz boost clock on the P cores and 24 MB of level 3 cache, it should be a strong performer. And of course, as a K-series CPU, you can overclock it as well. Power draw has lifted up to 180 watts quoted. Do note that the peak boost speeds are just on a single core, and they're really applicable to gaming scenarios. You may not achieve or sustain those numbers, but we'll look into that a little bit more later in our testing. So first, let's take a look at some synthetic tests. These are benchmarks designed to push the CPUs to their limits, so that we can gauge their performance relative to other options. First up, there's Cinebench R23 to get a view of overall multi-core performance and single-threaded capacity too. I hope you don't mind that for the new Zen 4 Ryzen parts I've used verified results from CPUmonkey.com, as I don't have those parts available for direct testing. You can see here that the i9-13900K jumped straight to the top of our charts with a score of 40,409. This is us testing with DDR4 RAM, although RAM has limited impact on Cinebench results. It's posting pretty well above the Ryzen 9 7950X, although that CPU is in the same ballpark of performance. If we look at the i5-13600K, we can see that with a score of 24,000, it's just pipping the last generation i7-12700K in the performance stakes there as well. Looking at the single core scores, that's indicative perhaps more of gaming performance as a rule, and you can see that both of them post healthy results. The i9 posts 2,200 points, which is above anything else in our chart. And the i5-13600K, with that slightly lower boost clock and slightly less level 3 cache, is down just below 2,000 points, and again just slightly beats the i7-12700K of last year. In single core score, the i5-13600K does beat the Ryzen 5 7600X, but not by a huge margin. You're not going to see a massive difference in performance. Do note the one anomaly on this chart: the Ryzen 7 5800X 3D scores low in this test due to its lower clock speed, but in fact its level 3 cache makes up for it in gaming, and this score really isn't representative of the strengths of that CPU. Moving on to 3D Mark Timespy, just a quick test of the physics on this one. We're looking only at the CPU score result. We can see again that the i9-13900K is by far at the top of the chart, nearly touching 20,000 points. It's significantly beyond the i7-12700K from last year, with those additional E cores and very high clock speeds all yielding a great result. The i5-13600K again touches on the performance of the i7-12700K from last year and roundly beats previous generation CPUs and the 5800X as well, the Zen 3 CPU from AMD. And finally, just to look at another benchmark in terms of productivity, Blender is an all-core workload. It's very intensive, and it will utilise every core the CPU has to do this parallel workload. They have changed the 3.3 render testing, so again I've included results from their verified results, just to give an indication of performance versus the Ryzen parts. Here we can see that the i9-13900K actually performs just slightly behind the Ryzen 9 7950X. So it looks like 8 fast cores and 16 slower cores is slightly beaten by the 16 very fast cores of the Zen 4 part in this test. Meanwhile, the Ryzen 9 7900X comes in around 500 points, about 100 points down on the 13900K. The i5-13600K again slightly beats the i7-12700K in this test, showing the advantages of that high clock speed and those additional E-cores for this generation. Just to make it abundantly clear, if you are looking at a CPU to use for Blender, bear in mind that actually what you want to be doing is using a GPU. You can see here the scores posted by the RTX 3080 and the RTX 3080 Ti in the same benchmark are a clear order of magnitude bigger than any CPU, and you really do want to be using a GPU to do rendering workloads wherever possible because they're just vastly more efficient at it. So overall then, we can see that in the synthetic testing, the 13th generation is holding up well. The i9-13900K is topping the charts or coming very close to the new Zen 4 7950X in almost all metrics. Its single core speed is also very high. The i5-13600K meanwhile beats or matches the i7-12700K from last generation, but at a slightly lower price point, making it an attractive option. We've set up a site called buildpicker.com. It's designed to take the pain out of part selection as you choose to build your next PC. It uses a system whereby components are grouped according to their performance and capability. We then select from those groups for the best price options, making sure that equivalent parts are compared so that the build is always going to be the best it can be at any given price. We've got Intel and AMD builds on there, so there's plenty of options for you, and we've also categorised them according to the programs and titles they're going to perform best in. We'll be updating it very shortly with all the parts from AMD's Zen 4 lineup, as well as the Intel 13th generation CPUs, to ensure that you're getting a bang up-to-date build that's the very best for your money. Check out buildpicker.com. Let's move on and take a look at gaming. So first up, it's Rainbow Six Siege, and it's no surprise here that the i9-13900K with that very high boost clock and large level 3 cache tops our chart. It's the fastest CPU we've ever tested for this benchmark, averaging 621 frames a second and beating all the other CPUs for both minimum and maximums as well. It is, however, I would argue overkill to use this CPU for a game like Rainbow Six Siege, and you can see that the i5-13600K also does brilliantly. It basically matches the i7-12700K and provides obviously an excellent experience in this title. Far Cry 6 is also quite intensive and does scale pretty well with CPU cores. And again, you can see the i9-13900K comfortably at the top of the chart, with the i5-13600K just behind it, and the i7-12700K just below that. We're testing here at 1080p high settings with an RTX 3080, and again I would simply argue that if you're looking for an all-round gaming CPU, whilst the i9 does come top of the chart, you are spending a large premium, not just in the CPU, but also in the other supporting components you need, just to get a few frames per second here. There are better ways to spend your money, but nonetheless, it's giving great results. Looking at Shadow of the Tomb Raider, and here we're digging under the hood a little bit, these results are the CPU game engine results, not the overall benchmark results. Again, you can see that the core speed and cache of the i9-13900K is really letting it shine here with an average FPS of 305. Some way behind it is the i5-13600K, which again matches very closely the performance of the i7-12700K. And finally, we've rerun our flight sim testing with these two CPUs just to ascertain their performance in that title. This is the London Heathrow 747 takeoff, which is one of the more CPU bound scenarios we run. And here you can see that the i9-13900K is top of the chart. It runs very, very well in this test, and it's unfortunate we don't have Zen 4 parts available to check, because I'd love to test either the 5800X3D or some of the new Zen 4 parts just to see how they fare in this test, see if they give a performance advantage. Nonetheless, it does excellently with 69 frames per second average and solid results in the 1% and 0.1% lows. The i5-13600K also beats out the i7-12700K. Again, it's clear that the architectural improvements this generation have just yielded incremental improvement, and this CPU is stronger than the outgoing i7 part. I've included the rest of the CPUs just so that you can see how this test does scale, with CPU performance, but not necessarily core count. Note the weak performance of the i9-10850K despite it having 10 cores. Again, these are architectural improvements and level 3 cache that really assists this benchmark. So to round up our gaming testing then, we can see that these are very high performance gaming CPUs. Obviously the i9-13900K with that large cache and very fast individual core speed and boost clock speed means that it is top of the tree in most gaming tests. However, simply for gaming, I would argue it's probably overkill. You're going to get better value with an i5 or an i7 part, or perhaps one of the AMD offerings like the Ryzen 7 5800X3D, which is still one of the highest performing gaming CPUs you can buy. Meanwhile, the i5 part, the i5-13600K, is just slightly hamstrung by the product segmentation that Intel put in place, with that lower 5.1 GHz clock speed and smaller level 3 cache, which means that it's lacking slightly in gaming performance. I do wonder whether Intel would be better off making the i5 part less of a do-it-all with the E-cores as well, and perhaps cutting down those E-cores in favour of higher boost clocks on the P-cores, meaning that it would be a better performer in gaming. Nevertheless, it's a K part, so you can overclock it, and it will have good memory flexibility as well, allowing you to optimise it that way. So there are options to increase the performance of this CPU, and it does remain affordable at around $300. Now let's take a look at the power demands and thermal characteristics of these CPUs. Intel CPUs have long been criticised for using a lot of power and running hot, and the Intel 13th generation doesn't appear to depart from that reputation. First up, let's take a look at a Blender run on the i9-13900K. You can see here that the P-cores hit 5.5 GHz with ease, and do maintain it for the duration of the run. Meanwhile, the E-cores are sat quite happily at 4.3 GHz, and they do lend a substantial amount of processing power to this kind of workload. The CPU is 100% utilised through these tests. That does bring some problems with it. We were using an Arctic Liquid Freezer 240 CPU cooler in these tests, and you can see that the CPU package temperature does hit 95 to 98 degrees Celsius, and on occasion individual cores did throttle. The other issue here is power draw. This CPU was drawing 300 to 330 watts throughout this run, and that is a significant draw of power, and that brings with it the need for significant cooling. Again, if we look at Cinebench R23, we can see much the same story. This again is an all-core workload, and it will simply demand as much as the CPU will give. This is stock out-of-the-box performance on a Z690 motherboard, and again the CPU P-cores sat quite happily at 5.5 GHz all-core, and the E-cores were sat at 4.3 GHz. Meanwhile, the CPU was drawing 320 to 330 watts, and the CPU was very quickly reaching temperatures of 94 to 95 Celsius in this test. We thought we'd take a quick look at the claims that this CPU will hit 5.8 GHz, and to our surprise it absolutely does. In any CPU you'll have a couple of cores that are noted to be best performers. In this CPU they were Core 4 and Core 5. Running a single threaded workload on Cinebench R23 allows the CPU cores to boost to their peak, and this CPU did cleanly boost to 5.8 GHz on Core 4 under that workload. You can see that it's not consistent. It doesn't simply load one core maximally, it actually shifts the workload around between cores. However, this CPU core can be seen hitting 5.8 GHz, and that's without any user intervention whatsoever. That is just stock behaviour for this CPU on a Z690 motherboard. But it does appear that Intel are being honest when they say these CPUs will hit 5.8 GHz. It also indicates that it's very likely that 6 GHz is within reach with a mild overclock. It's not something we've had time to apply ourselves to yet, but I've no doubt that if you do want to try for a magic 6 GHz, you will be able to achieve it on these CPUs, given the right supporting equipment. If we take a look at the i5-12600K under a multi-core workload, again you can see that it adheres to the specs as advertised by Intel. It does boost to 5.1 GHz on the P-cores and 3.9 GHz on the E-cores. However, power and thermals are again a problem. We saw around 260 watts average on this CPU during a multi-core workload, and that leads to temperatures in the mid to high 90s on a 240mm AIO. Whilst Intel have stated they've lifted the power requirements for these CPUs, with the i5 being quoted at 180 watts and the i9 being quoted at around 250 watts, we've actually seen significantly higher behaviour than that under stock operation on a motherboard with power limits removed. So if you want to overclock these CPUs or run them for extended durations with power limits lifted, you will need to ensure you've got a really good quality cooling solution, and you will also need a motherboard that's got VRMs that are up to task. I'm not saying you should immediately go out and buy one of the very high-end motherboards. We only tested this on a Z690 Tomahawk and a Z690 Carbon after all. However, it will need decent voltage regulation and good cooling to ensure stable operation of this CPU. And just in case you're worried about the i5 thinking it'll draw 260 watts all the time when you're gaming, that's not the case, and we logged some data just running benchmark of Shadow of the Tomb Raider so that you can see more normal behavior for the CPU. Here you can see that really even on the P cores the clocks are bouncing around on any particular core, and it's not fully loading the CPU. You can see P core frequencies between around 2000 and 4000 megahertz. And you can see that average power draw is much lower. It generally stays at around 100 watts or less in a normal gaming workload. Temperatures stayed well in control, around 50 to 60 degrees Celsius throughout this benchmark. So for normal gaming use, you won't need an absolutely top tier cooler, a 240mm AIO, or a strong tower cooler like a Noctua NHD15 or an AK620 from Deepcool will be adequate for the i5. However, we will need to do a little bit more testing on the i9 to work out what kind of cooler is really going to be adequate and whether it's actually possible to cool it sufficiently with an air cooler. So let's conclude then. First up, the i9-13900K. This CPU is an absolute monster, with those 24 physical cores giving amazing performance in multi-core workloads, productivity workloads, rendering and things of that nature. Meanwhile, the boost clock of 5.8 GHz and that large level 3 cache means that it's excellent in single core and gaming workloads as well. It's also really nice to have a CPU that simply performs out of the box. Those of us that remember the 11900K release will remember the pain that came with trying to extract reasonable performance from that CPU. The i9-13900K is a different story. Our example boosted to that 5.8 GHz individual core speed straight out of the box and maintained 5.5 GHz on the P cores in multi-core workloads. It took very little setup, and it also performed very well with both DDR4 and DDR5 RAM, although we will have a video exploring the RAM compatibility and performance a little more in the future, so do like and subscribe if you want to know more about that. That said, there are some caveats. It does use an awful lot of power. With 330 watts, you are going to want to watch it, particularly if you're intending on using it in productivity workloads where you're going to run the CPU at full capacity for extended periods of time. In that situation, you are going to need to pay close attention to which cooler and motherboard you sandwich this CPU in between. You're going to need a very strong cooling solution, and you will need a motherboard and, for that matter, power supply that are capable of supplying adequate power for long periods of time. You could also look at options like undervolting it, or perhaps even disabling some E-cores if they're not particularly useful in the workloads you're subjecting it to reduce overall power consumption and therefore the thermal load this CPU can generate. However, this is unashamedly an enthusiast product, and just as Porsche buyers don't particularly care about fuel economy or the cost of tyres, I suspect that people who are drawn to the i9-13900K aren't going to be particularly put off by the power usage, and in fact some of these things are a feature, not a bug to that kind of user. It's nice to be able to engineer a really effective cooling solution, as well as ensure that you've got a top tier motherboard and you've spent the time tweaking it to really get the most performance out of this CPU. It does get a hearty recommendation from us, but it's probably not the best option for most users. If you're not an enthusiast or you're not using it in very intensive all-core workloads, there are going to be better options elsewhere in the Intel lineup. Moving on and looking at the i5-13600K, this is a CPU that continues to blur the lines between the i5 being the everyman gaming CPU and the i7 being a multi-core workhorse. With those 8 E-cores and relatively powerful P-cores, the i5 basically matches the last generation i7-12700K in most tasks. It does that at a slightly lower price point. However, there is the slight compromise in that in all-core workloads we are seeing very high power usage, again around 250 watts, and therefore you are going to want to investigate a very good cooler to pair with this CPU, a strong motherboard, although it doesn't really need to be overkill, most mid-range motherboards will do the job, and also you are going to want to look at options like undervolting it, particularly if you're going to start overclocking and trying to get more performance out of it. At that point, power management and thermal management will become a priority. Overall though, it is a very strong CPU, but we would consider certainly looking at things like the i7-12700 or 12700K. If you're finding those discounted to around the same price, we'd view them almost as equivalents at this point, with 8 P-cores on the i7, the last generation, really making up for the additional 4 E-cores that you're going to get on the 13th generation i5. They're kind of a mix and match, and we wouldn't feel shortchanged with either CPU. They both perform really well. Looking at the two CPUs we've tested, we can infer some information around the i7-13700K as well. It looks like it should be a happy middle ground between these two CPUs, with 8 P-cores and slightly higher boost clocks on those P-cores, meaning it will perform basically in the middle, particularly for gaming, of the two CPUs under test. It will likely still be the sensible option for people who haven't got an unlimited budget but want a really strong all-round CPU, perhaps with mixed usage workload, a bit of gaming, some productivity work as well. It will be a CPU you're going to be able to buy with confidence. Do just check out pricing. You could also find, for example, discounted i9-12900Ks or i7-12700Ks if you're cost conscious, and they're still really strong performing CPUs. You're not going to feel shortchanged if you opt for those 12th generation parts, particularly if they come with a cash saving that mean you can upgrade your PC elsewhere. To consider some alternatives to these CPUs, there really isn't much in terms of AMD's offerings at the moment on a cost basis. There is the Ryzen 7 5800X3D, which is still basically the strongest gaming CPU you can buy. It fits on a cost-effective AM4 platform with DDR4 RAM, meaning that you can build a really high-performance gaming PC for not a great deal of money. It's certainly worth considering if gaming is your priority, particularly high frame rate gaming. Looking at the newly released Zen 4 CPUs, they do suffer a little bit of a problem from pricing in the face of these 13th generation CPUs from Intel. The 7950X is undoubtedly a high performer. It matches the i9-13900K in some multi-core workloads and falls slightly behind in single-core workloads. However, it requires expensive motherboards, as well as DDR5 RAM. With Intel, at least you have the option of cheaper Z690 motherboards or even B660 motherboards for some of these CPUs, as well as DDR4 RAM, meaning you can massage the costs to fit your budget. With the Zen 4 CPUs, you are really committed to the whole spend, and particularly when you're faced with a $300 7600X, it doesn't make a great deal of sense then to spend $250 to $400 on a motherboard and another $250 on RAM for a CPU that is ultimately just a 6-core CPU with a focus on gaming. You're looking at a very expensive platform cost, and we'd suggest that something from Intel, the i5 or i7 CPUs, is going to allow you to build a much better PC, perhaps with more money put into the GPU, where you will get more performance for your buck in gaming. You can also look back to Intel's 12th generation as they get discounted. They work on the same motherboard platforms, and they're still really strong CPUs. You can get a discounted i7-12700K, and you will not find it lacking at all in gaming or productivity use. If it's around $300, we'd consider it an equivalent to the i5-13600K, and we might slightly prefer the i7-12700K just because of its less aggressive power use and those 8 performance cores. Overall though, the 13th generation looks to be a really strong option from Intel. We've been really impressed with these CPUs, and across the range we think you'll find something for pretty much every budget and need. If you are at the budget end, don't feel shortchanged. The i3-12100 and i3-12400 still exist, and they're still really good options for general use and gaming PCs. However, the 13th generation should bring forward some minor enhancements in those lower tier parts, and we'll look forward to seeing how they perform as well. Hopefully the 13th generation i3 and i5 will continue the strong options available to people with a more limited budget, and will fit into more cost-effective motherboards to build a really strong general purpose PC. I really hope you found this video useful. We will be doing further videos on Intel's Raptor Lake, including the best RAM pairings with these CPUs, as well as cooler options and investigations into how best to cool the high power output of the i9-13900K. If that's content that interests you, please do click like and subscribe so that you'll be notified when it's available. In the meantime, do check out buildpicker.com.